Continuing lesson 1.4 on square roots and cube roots, if we look on page 27 at example 3, Sean cuts one sheet of colorful poster paper to cover the bulletin board exactly. What are the dimensions of the poster paper? So if you look at this picture, you can see that this bulletin board has an area of 144 square inches. So if that's the area, we know the area of a square or area of a rectangle is length times width. And that works for squares also. It's just in a square, the length and the width are going to be the same. So basically we're thinking of a number times itself. If they're both the same, a number times itself, that equals 144. And so that means really we're looking for the square root. A number times itself that equals 144. That sounds like the square root of 144. And so if we think about that, a number times itself that equals 144 would be 12. 12 times 12 is 144. So this would be a 12-inch by 12-inch square is what we would need to exactly cover that. So we'll look at the try it. Emily wants to buy a tablecloth to cover a square card table. She knows the tabletop has an area of 9 square feet. What are the minimum dimensions of the tablecloth Emily needs? Okay, now this is going to be a little bit weird because usually a tablecloth actually goes down the sides of the table. This one, if we went with the minimum, it would be just strictly covering the top of the table with no overhang on it. Okay, which it's fine. It would cover the table, so it works. So since it's, first of all, since it's square, we know the length and the width are going to be the same. We know it's got an area of 9 square feet. So once again, we're thinking area is length times width. Length and width are the same, and the area is 9. So a number times itself, that equals 9, okay? So number times itself, that equals 9, that would be the square root. And that, we could show this here if we wanted actually working this out. You might remember, we've talked about before, if you were doing a problem and you did a square root, technically we put plus or minus if we add the square root symbol, even though we know we can't have a negative side length, we can eliminate that possibility. So square root of 9 is 3 because 3 times 3 equals 9. Okay, so whether you show all these steps that I'm putting here or not, ultimately you would want to probably put something about, square root of 9 and 3 feet. Square root of 9 is 3 feet. So then when they ask what would be the measurements, then that would be 3 feet by 3 feet. Okay, and like I said, that's going to just barely cover the top of the table with no overhang. So recap real quick with the key concept. I guess if we want to look at the square root first, square root, we've got a number times itself that equals that number. So square root of 4, a number times itself that equals 4 would be 2. Also we have the cube root. So cube root is a number times itself 3 times that equals that number. So cube root of 125, we need 3 factors that are all the same that we multiply to get 125, and that would be 5, because 5 times 5 times 5 is 125. So we're going to look at the do you understand number 3. A cube-shaped box has a volume of 27 cubic inches. Bethany says each side of the cube measures 9 inches because 9 times 3 equals 27. Is Bethany correct? And explain your reasoning. So actually for this, for volume, we've got a length, width, and height we're multiplying together. So if we were saying that it's 9, each side is 9, we would be doing 9 times 9 times 9. And that's not going to be 27. 9 times 9 is already 81, so that's already way too much. So we could think about this, though. Okay, like I said, that won't work, but we could think about what would give us a volume of 27, and we could think about if it's a cube, we know the length, width, and height are all the same. So S times S times S, if you wanted to, that's the same as S cubed. So something cubed equals 27. If we were trying to figure out what that something is, we could take the cube root of 27 then to figure out what that side length is. And so that would be 3. So 3 inches would be a side length, because 3 times 3 times 3 equals 27. So it'd be 3 inches by 3 inches by 3 inches. We go to number 4 on the do you know how. A cube has a volume of 8 cubic inches. What is the length of each edge of the cube? So once again, we could think of a cube as length times width times height. All of those are the same in a cube. And so if the volume is 8, something times itself 3 times, that equals 8. So we would want then the cube root of 8, which would equal 2. So 2 inches. 2 inches would be the length of each edge, because 2 times 2 times 2 equals 8. Number 5, below is the model of the infield of a baseball stadium. How long is each side of the infield? So you can see on the infield part, the area is 81 square inches. So we're back to area on this one, which is length times width. We know if it's a perfect square, our length and the width would be the same. And so if our area is 81, we could take the square root of 81. Or think of a number times itself, that equals 81, right? And so that would be 9. So 9 inches would be our side length, okay? And this is a model, if anybody was wondering. This is a model. 9 inches for a base path, otherwise you'd take one step and you'd already be to the base. So people would be stealing bases and be constant scoring, I guess, on this game if it wasn't a model. If we look at number 6, Julio cubes a number, then takes the cube root of the result. He ends up with 20. What number did Julio start with? So if you cube something and then you take the cube root, those are kind of like opposite operations. Kind of like if you add 5 and then you subtract 5. So if you cube something and then you take the cube root, that's going to get you back where you started. So if 20 would have been the starting point. So if you did 20, so 20 cubed would be 20 times 20 times 20, which would be 8,000. And then if you did the cube root of 8,000, then you would get 20, right back where we started. If you want to look at a few problems in your workbook here, it's workbook page 7, starting with number 6. Nadia wants to enclose a square garden with fencing. So, maybe we just draw out the garden here. Draw out a square. So it has an area of 141 square feet. To the nearest foot, how much fencing will she need? So if we think about this, we could do area is length times width. Our area is 141. Length and width are the same here, so if you wanted to call them S's, you could do that. Okay. So if a side squared equals 141, if we did the square root, technically we put plus or minus there, but we can't have a negative side length. Okay, so square root of 141 would tell us, if we work that out, it comes out not very nicely. This is an irrational. So this is about 11.9 feet. So that's telling us what one of the sides is on our square. Most of the problems we've been doing to this point, we do one thing, we get an answer, we're done, we move on to the next problem. That's not the case on this problem. If you read this question, it says, to the nearest foot, how much fencing will she need? So 11.9 feet, that's not our answer yet. So to figure that out, basically we need to find out what our perimeter is. The fencing material goes around the outside of this thing, so we need to find the perimeter. So we could either add 11.9 to itself 4 times. Now that's rounded, understand. We did round that off, but that's going to be pretty close. Or we could multiply by 4. Whichever way you want to do that. So whichever way you do that, you should get 47.6 feet. And we're almost done. So we still need to round this to the nearest foot. So we're going to round to 48 feet, whichever way you do that. We'll round to 48 feet, okay? And I would argue in this case, real life scenario, even if you got like 47.2 feet, 47.2, you'd say, oh, it's closer to 47. The problem is we're going to have a hole in our fence, and then the animals are going to get in very easily, and to where there's a, our fence really is not doing us any good if there's a gap in it, right? So for this problem, we'd always really want to round up to the next nearest foot that's above that. If you look at number 7, Benjamin rents a storage unit that's shaped like a cube. There are 12 identical storage units in each row of the facility. Okay, so he's renting one of these. There's 12 identical ones in a row. Okay, if you've ever been to one of those storage places where people keep their stuff. Each storage unit has a volume of 125 cubic feet. What is the length of each row in the facility? Okay, so let's look at this. Let's just look at one of these to start with. If we just think of one cube. Okay, so the volume of one of these is 125 cubic feet. So one of the things we're going to have to do is figure out the dimensions of one of these storage units. So if the volume is 125, like we've talked about before, volume is length times width times height. And on a cube, all of those are the same. So to figure out what our side length is, we could take the cube root. So cube root of 125. Sorry, that was a little sloppy. So that would be 5. So that means one of our side lengths here is 5 feet. So basically each one of these storage units is 5 feet by 5 feet by 5 feet. Okay, now once again, we're not done with the problem. The problem was, what's the length of each row in the facility? So if we have 12 of these next to each other, it's kind of like this maybe. We've got 12 of these things. I know I'm not doing that justice. Those are all supposed to be evenly spaced, okay? But if each one then is 5 feet wide, right? And we've got 12 of them, then we could just multiply 5 times 12 or 12 times 5, which would be 60 feet. So 60 feet would be the length of each row in the facility. So this gives you an idea of how to work with square roots and cube roots. Have a good day.